If you're familiar with AIs or LLMs, you've probably heard the term vector database get thrown around a lot. It's one of those terms that you're probably nodding along in a meeting or maybe skimming past it in some kind of AI article, well, maybe never knowing the true definition of that term. But by the end of this video, you're going to understand exactly what a vector database is, why everyone is suddenly talking about it, and how it actually works. Hi, my name is Dawn. I was a data scientist at Meta and a business intelligence engineer at Amazon. Now, I teach AI and data science for a living. Let's get into it. Let's start with what is a vector database. So you're probably familiar with traditional relational databases like your SQL databases. These databases typically allow you to search on exact matches. So you might say filter on this user ID, or maybe give me data before this date. And it goes through the table and finds the rows that match those exact conditions. A vector database, on the other hand, works completely differently. It allows us to search based on meaning, not keywords. So for example, if you search for heart attack, it might pull back a result that includes cardiac arrest. So even though those are completely different words, we know, and the vector database knows, that they mean basically the same thing. So the takeaway here is that a vector database lets you search for things with the same meaning contextually, even if you're not typing the exact same words. Now, let's talk about why vector database suddenly have become like the hot girl. Why is everyone suddenly talking about vector databases? And it comes down to one big AI concept, and that's RAG, Retrieval Augmented Generation. The big AI models like ChatGPT and Claude, they only know what they're trained on. They've never seen your company's internal doc or even your own data, which means that the moment you ask for something specific about your own information, they'll either hallucinate or just tell you they can't answer your question. The fix for this is RAG, Retrieval Augmented Generation. Basically, before an AI model answers your question, it'll go out and find the most relevant pieces of your own documents first. Then it'll take those chunks that it finds, hands them to the model as relevant context, and then your AI can answer your question with the context from your company. But there is a catch to this. The AI model can't match on keywords alone because different people are going to ask the same question in their own words. So this means it has to search on meaning, not exact keywords. And searching by meaning is exactly what a vector database is built to do. So now that all comes full circle. The reason vector databases have suddenly shown up a lot more in conversation is because of RAG and LLM. So vector databases have always existed, but they've gone from being a niche use case to a very common one. Now let's talk about how vector databases actually work. Now this is going to be a very simplified version of it, but it's going to give you enough context that you can understand how it works. So let's talk about how a vector database does a semantic or a meaning-based search. So think of every piece of text you feed into a vector database being turned into a list of numbers. That list of numbers is called an embedding, and the whole job is to capture the meaning of your text as numbers. So again, I'm just going to say that one more time. Vector databases allow you to take text and turn it to numbers where the numbers represent some kind of meaning. And here's the really cool part. Every embedding sits as a point in space. What that means is that words with similar meanings end up close together in this multi-dimensional space. So for example, the word cat lands right next to kitten, but both of them are probably going to be really far away from something like invoice. So every time you run a search, your question gets turned into one of those points or an embedding using the same process. And then your vector database is just looking for points sitting closest to the point that you just searched. These closest points are called your nearest neighbors, and they are your best matches. But let's think about the case once you have millions of these points. Checking your question against every single one of those points would be way too slow. So the database built something called an index, which is basically a shortcut that allows you to find the closest points without having to look at your millions of data points. So quick summary here, vector database turns text into numbers which exist as points in space. And when it searches on meaning, it finds points that are close to each other. All right, let's talk about vector databases versus SQL databases. So how do these compare to the SQL databases that you are probably very familiar with? Think about it like this. A SQL database is good for keyword search and exact matches, right? So give me all the customers in Texas that spent more than $100. It filters to the rows that match those exact conditions. But a vector database is built for a completely different type of question. Instead of asking who spent over $100, you can say something like, can you find me customers who shop like John with these characteristics? The database would then look at the whole pattern of what customers bought, what they tend to purchase, how often, the price range, etc. And it's going to find you the customers that look most like John. And nothing in this process ever looks for a keyword search. So how would you decide which type of database to build? If you need to use exact filters or anything with numbers that have to be exactly right, you're perfectly fine using SQL. This is really good for your standard data and analytics reporting. But if you need to search by meaning, product recommendations, or if you ever need to search through a bunch of documents, that's when you would use a vector database. Honestly, a lot of real apps just use both at the same time, right? So they have SQL databases for hard facts, and then they also have vector databases for RAG and the more fuzzy searches. Let's talk about, do you actually need a vector database? Do you need to spend the work to set up and maintain a dedicated vector database for your project or for your company? Well, maybe not. Let's talk through that. So if your team is already running on Postgres, then you might be able to do a vector search right inside of Postgres using a free add-on called pgvector. pgvector allows you to turn your regular Postgres database, store embeddings, and find the nearest matches very similar to a vector database. So you don't need to build a whole separate system, but there is a catch. That really only works up to, I think, either a million or tens of millions of data points. Anything beyond that, where you're to search a much wider range of data points, you're going to want a dedicated vector database. So for most projects, you're probably fine with a pgvector database. When you actually want a dedicated vector database is when you get into hundreds of millions of vectors and data points, or when you need very extensive filtering on your data while keeping it pretty fast. That's when you want to build out a dedicated vector database with tools like Pinecone, Qdrant, or Weaviate. Now, takeaway here, before you go ahead and start building out a vector database, make sure you really need one. If you're already running on Postgres, you might be able to get away with just pgvector, and it's really going to simplify your system. Building and maintaining a dedicated vector database does take a lot of work and time, and so I would only go through the effort if you have decided that you really need one. So to recap, vector databases search by meaning instead of by keywords. And RAG is the reason that vector databases have become essential, because it allows you to pull context directly from your documents. Under the hood, a vector database is just converting your text to numbers or embeddings and find the nearest neighbors in the retrieval process. If this actually made vector databases click for you, let me know in the comments, and subscribe if you want to see more of these AI fundamentals broken down like this. All right, everyone, I'm rooting for you. Now get to work.